Hello everyone and welcome to another Leetcode. So today we'll be doing a medium question about trees, which is the binary tree right side view. So given the root of a binary tree, we have to imagine ourselves standing on the right side of it, so something like this, and return the values of the nodes you see from the top to the bottom. So using example 1 right here, it will be like we are standing right here, and then we have to look at these values respectively, which is 1, 3, and 4. Because the other values right here, which are 2 and 5, will be blocked by 3 and 4 respectively. So that's why we only see 1, 3, and 4. And likewise for example 2, it will look something like this. And so if you are sitting right here, we will only see 1 and 3. Okay, so my initial intuition in handling this problem is that what I will do is that I'll simply be at the root and I'll keep recursing to the right until I reach a dead end, which means that at some point it will be a none on the right side of the tree. So basically what I will do is I will get the 1 and then I recurse to the right to get a 3 and I recurse to the right to get a 4. At first glance it seems like this method does work, but what I've never taken into account is maybe another edge case whereby perhaps this 4 might not have exist and this will be the 3 right here. So if I'm standing right here, what I should actually see from the top to the bottom is 1, 3, but I should also see 5 as well, because it's not being blocked by anything. So that will mean that my initial approach doesn't work. So how do we come up with a solution then? One thing we have to recognize is that basically our main important goal is to get the most right element at each level. So if you consider this to be level 0, level 1, and level 2, we want to get the most right element at each of these levels respectively. So what is something that we can do to help us? That's right, one thing that we can do is to use level order traversal. So basically I'll keep traversing right at each and every level of the tree to get the most right element. So what this means is that basically at the start, I'll have a queue. And inside this queue, I'll be appending the node at the current level that I'm on. So let's say I'm currently at this root, I'll be appending this node as well as level which will be 0 at the start. So here, I just have a level which will begin at 0 as well. So what I will do is I will do the level order traversal, which I've already done a video on that and you can check it out. So how this algorithm works is that what I will do is to pop the first element from the queue. So in this case, I will have popped out this 1, which has a level of 0. And then I will append the children to it. So how do I know what's the next level of the children? So it will definitely be level plus 1, right? Since it's the direct children of the current node I'm looking at. So that will mean that when I do the appending, I'll be appending the new node, as well as the new level, which will be 1, as well as the other right child, which will be 3 and 1 as well. So I'll be updating the new node. Now the question is, how do I know when I have reached the most right element? So what I can do in this case is to have another temporary variable, which will store the current element. So in this case, when I pop out 1, I'll store the value as 1. And how to tell if I have the most right element? Now, if the next node that I pops is from the next level, then that will mean that the current temporary value that I have will have been the most right when the node that I currently pop is at the next level, which makes sense, right? Because for example, if I'm at 2 and I see that the level has changed, so that will mean that 1 was the most right element. And for example, when I take a look at 5, before I even hit 5, I'll have to go through 2 and 3 before I can hit 5. So at that point in time, while I'm at 5, the value right here will be my temporary value that I have updated. So that will mean that the moment I hit a next level, the latest temporary value will have been the most right element. And this will be how the order will go. But what if the next node is not the next level, but instead is still on the same level? Then that will mean that my temporary value has to update as well with the value, because it will keep going to the right. So as long as it's on the same level and I keep popping it, then I have to keep updating my temporary value to be the next element on the right. And in that case, when I hit the next level, then my temporary value will truly be the most right element. And as such, this will ensure that I do get the correct answer every time. So basically, if I'm on the same level, then I will just update the temp. But if I'm the next level, then my current temp will be the most right. And with that, we have found an algorithm to help us to get the most right answer, which is just a variation of level order traversal. Now, to make things clearer, we can move on to the coding explanation. So as always, let's start with some pseudocode first. So what we'll be doing is a level order traversal, and I'll take the most right element at each level. Okay, so let's just settle a very simple base case first, whereby my current root is already none. Then I can just simply return none, because I wouldn't have any output to return in the first place. But if not, then I'll initialize my variables. So what I'll have is a queue, and I'll have an initial level which starts at 0. And then what I will do is to add a 2-value array, which will be my current node and the level, to the queue. But initially at the start, it will just be the root. So while my queue is not empty, I will pop the first element, because I need to do a level order traversal. So I need to always start from the most top and the most left. So I pop the first element, and I'll check and this element right here, it will be an array because of the node and the level, right? So I'll check the level of the element. If it's the same, I will update a temp. So basically, I'll have another temporary variable so that I can keep updating the latest value to the right. But if the level is already higher, then my current temp will be the most right element. So I add the most right to the temp. I add the temp to my output, which will be returned. So basically, so I guess for my variables right here, I also need a values array, which will be my output. Okay, and then after that, I will add the left and right child to the queue of the current element I'm looking at. But I also have to take note that when I pop the first element, I have to check if the node is not none, before I proceed on with all these checks. Because if it's none, then it's a trivial matter. I don't have to check it anymore. Now while I have this code right here, there's also an edge case that I have to look at, which is at the end. Because what happens at the end, right, is that I will never reach a level that's already higher to add my current temp. So for example right here, if I'm at element 4, there isn't a value that's lower than this for me to trigger adding of the current temp to the output. So at the end, I have to add the temp again. Because like what I mentioned, the 4 right here will have been a temp that I should add to my output, but it doesn't trigger this line of code right here because there's no further values below. So at the end, I have to do so again. So let's just start out with the code right now. So let's handle the trivial case. So if my root is none, then I just return none. I also have my variables. So I have a queue, which I'll use an array right here, and my values will be an array as well. The level will be starting at 0. So because it's not none already, I'll just add my root level to the queue. So queue will be appending the root as well as the level that is at, which starts off at 0. And now let's handle the while part. So while my queue is not empty, what I will do is to get the first element. So the current one I'm looking at will be queue.pop 0. So the current node will be the first index, which is 0 indexed. Okay, there is a typo. Then the current level will just be the second index. So now I'll check if my current node is not none. Then I'll check the current level. So if my current level is still equals to the level, I'll just update my temp. Okay, so that means that I should have another temp variable right here, which I'll just set it to none in the first place. So if my current level is still the same, then I'll update my temp to be the current node value, because I'm moving towards the right. Else,
The only other case where the else will trigger is if my current level is one level higher. So I've ascended down to the next level. Then, as I mentioned just now, the temporary one will hold the latest element on the previous level to the right. So for example, if I'm at 5, it will have hold 3. So what I need to do is to append the value to my output array. And then I simply just set temp to be the current value I'm looking at, which is on the most left of the new level now. And what I have to do is to increment the level as well, since I've already moved down to the next level. And finally, once all these checks is done, I have to add the left and right child. So I'll be adding the left child, which has a level of +1, and the right child, which has a level of +1 as well. So that will be what will happen in the while loop. And as I've mentioned just now, at the end, I have to add the temp again. So values will have to append temp. And finally, I'll just return values, which is the answer. And I believe this should work. So for the time-space complexity, I believe that the time complexity should be a ON, because I'm doing a level order traversal, so I need to explore each and every node inside the tree. And the space complexity will be ON as well, because I'm utilizing a queue system right here. So I believe that this should work. See, the solution does work. And as always, if you have any questions, then feel free to leave them in the comments down below, and I'll do my best to help. So thanks for watching.